Hello students, how are you? I hope all of you are good. In this video, I am going to start a new chapter, three-dimensional geometry. And one thing to understand this chapter, first thing you must and should perfect the concepts which have been studied in the vector algebra chapter. So those who perfect the concepts of vector algebra, those who perfect the concept of vector algebra, they are going to understand easily. But those who don't know the concepts of this chapter, vector algebra, they are going to face some problems to understand this chapter. So that's why my strong suggestion to you people is first you should perfect the concepts of the chapter vector algebra before going to start the study of this three-dimensional geometry chapter. So let's start. So today's class is on what? Introduction part for the first exercise. That is what? 11.1 of the chapter three-dimensional geometry. So this introduction part consists of totally four concepts. The first one is direction, cosines and direction ratios of a line. And second one is relation between direction, cosines of a line. And third one is direction ratios of a line joining 2 points. And the fourth concept is, I just want to insert here, collinearity of 3 points. What is the fourth concept? Collinearity of 3 points. Collinearity of 3 points. And lastly, I am going to solve some of the examples based on these four concepts. So let's start the first concept. The first concept is what? Direction, cosines and direction ratios of a line. See here. So for that, as you know that this is a x-axis, y-axis and z-axis, and this one is the origin. So let us consider a line. Let us consider a line which makes an angle alpha with x-axis, beta with the y-axis and gamma with the z-axis. And these angles made by the line with the coordinate axis are called as direction angles. Already you have been known in the vector algebra chapter. And here the direction angles are alpha, beta and gamma. And hence the direction cosines is nothing but cosine of the direction angles. That is nothing but cos alpha and then cos beta and then cos gamma. So these are the direction cosines of the line. And one more thing, direction cosines are already denoted by what? L, M, N. So this thing already studied in your vector algebra chapter only. And one more thing you need to observe here, see here a line can extend in both the direction. A line can extend in both the direction. It means that by the concept of supplementary angles. Suppose here this is a line L1 and this one is a line L2. Suppose this line L2 making an angle theta with the line L1, then definitely this angle, so this side angle should be equal to 180 minus theta. By the concept of supplementary angle, straight angle is equals to 180 degree. So if suppose theta is equals to 30 degree, then definitely this angle should be equal to 180 minus 30, that is what? 150 degree. So therefore this line makes angle alpha and as well as this angle here, pi minus alpha with the x-axis, and same line L makes angle beta and what? Pi minus beta with the y-axis, and similarly z-axis makes gamma and pi minus gamma with the z-axis. So it means here we have one more set of direction angles here, and which are those? Which are those? First one is a pi minus alpha and second one is pi minus beta and third one is pi minus gamma. So these set is also one more set of direction angles of the given line. So cosine of these angles are also known as direction cosines. So it means the first direction cosine is nothing but cos of pi minus alpha, cos of pi minus alpha, and second one is cos of pi minus beta, and third one is cos of pi minus gamma. So by the allied angle formulas, we know that cos of pi minus alpha is minus cos alpha, and cos of pi minus beta is minus cos beta, and cos of pi minus gamma is minus cos gamma. So these are also one more set of the direction cosines of the line L. And as you know that cos alpha is denoted by L, it means minus cos alpha is minus L. And cos beta is m, it means minus cos beta is minus m. Cos gamma is n, so minus cos gamma is minus n. So L, m, n and minus L, minus m, minus n are the direction cosines of the line L. But for the calculation purpose, we use the first set of direction cosines always. But if he asks the direction cosines of a particular line in your MCQ section or in the KCET examination, so they may given first set of direction question as your one of the option, or they may give the second set of direction cosines as your one of the option. So that's why you need to know both the direction cosines. I hope all of you understanding. You must and should know to identifying the both set of direction cosines of the given line. I hope all of you understood. And see here one more thing I need to concentrate here, what direction ratios. So what I discussed now, direction cosines of a line. And next thing is what? Direction ratios of a line. See here, as you know that direction ratios means the numbers which are proportional to these direction cosines. The numbers which are proportional to these direction cosines. Suppose here, let's suppose P is one of the point. P is one of the point on this considered line and whose coordinates are A, B and C. Whose coordinates are what? A, B and C. And these numbers A, B, C are the proportional to these LMN. So already you know, the vector algebra chapter identify ಮಾಡಿದೀವಿ, check ಮಾಡಿದೀವಿ, prove ಮಾಡಿದೀವಿ. So these numbers, coordinates of the point P are what? Proportional to the numbers L, M, N. And these numbers are known as direction ratios of the line L. If I insert a direction from O to P, then position vector of the point P is, OP vector, and whose component form is, definitely it is equal to what? AI plus BJ plus CK. And these numbers A, B, C are what? Direction ratios of the line. These numbers A, B, C are what? Direction ratios of the line. And one more thing you need to observe here, magnitude of the OP vector. Magnitude of OP vector. So magnitude of OP vector is equals to square of I coefficient, that is A square, plus square of j coefficient, that is b square, plus square of k coefficient, that is what? C square. So this is what? Magnitude of the OP vector. And when direction ratios are given, when direction ratios are given or direction ratios are known, then the direction cosines L, M, N are, then the direction cosines L, M, N are given by the value of L and the value of M and the value of N. The value of L is A divided by magnitude of the vector. So A divided by magnitude of the OP vector, and M is equals to B divided by magnitude of the OP vector, and N is nothing but C divided by magnitude of the OP vector. I hope all of you understanding. Now here if I consider L square plus M square plus N square, then definitely it is equal to A square divided by magnitude of the vector OP square plus M square means B square divided by magnitude of the vector OP square plus N square means C square divided by magnitude of the vector OP square. So observe here, this is equal to, in numerator only magnitude of the vector OP square is exist. Therefore LCM is magnitude of the vector OP square. Malgade here multiply by 1, here multiply by 1, here also multiply by 1. So A square into 1, A square, B square into 1, B square, plus C square into 1 is C square. So observe here, magnitude of the OP vector is root A square plus B square plus C square. If I squaring on both side of this magnitude of the OP vector, then definitely on right side, square and square root get cancelled, remains A square plus B square plus C square. Therefore, in numerator, A square plus B square plus C square can be replaced by what? magnitude of OP vector square divided by magnitude of the OP vector square. So both get cancelled. Finally we got what? 1. The value of 1 is what? L square plus m square plus n square. And this is what? The second concept, relation between direction cosines of a line. So the relation between direction cosines of a line is L square plus m square plus n square equals to 1. Or we already known L is nothing but cos alpha when the direction angles are given, and m is nothing but cos beta, and n is nothing but cos gamma. Therefore L square plus m square plus n square is nothing but cos square alpha plus cos square beta plus cos square gamma, which is equals to 1. So this is also what? Relation between direction cosines of a line. I hope all of you understood. So one more thing I need to discuss here. A is nothing but direction ratio divided by magnitude of the OP vector is square root of A square plus B square plus C square. Since we are identifying the direction cosines of a line, so line can extend in both the direction. Therefore, the value of L can be taken as plus minus A divided by square root of A square plus B square plus C square, or simply plus minus A divided by magnitude of the OP vector. And the value of M is equals to what? Plus minus B divided by square root of A square plus B square plus C square, or plus minus B divided by magnitude of the OP vector. And the value of N is nothing but C divided by plus minus C divided by square root of A square plus B square plus C square, or simply plus minus C divided by magnitude of the OP vector. I hope all of you understood these two concepts, direction cosines of a line, direction ratios of a line, and what? Relation between direction cosines of a line. And the third concept is what? Third concept is direction ratios of a line joining 2 points. Now what? Direction ratios of a line joining 2 points. See here, to identify the direction ratios of the line joining 2 points, to identify the direction ratios of the line joining 2 points, just consider one of the line here. So let us consider a line. Let us consider a line which joins 2 points P and Q. And what? Q. So L is a line segment joining the points P and Q. And the coordinates of the point P is nothing but x1, y1 and z1. And the coordinates of the point Q is x2, y2, z2. So as you know that if PQ is a vector joining 2 points P and Q, then it should be equal to PQ vector. And PQ vector can be written as OQ vector minus OP vector. So OQ vector is a position vector of the point Q, and OP vector is the position vector of the point P. Therefore, PQ vector can be written as OQ vector is x2i plus y2j plus z2k minus OP vector is position vector of the point P. It is nothing but x1i plus y1j plus into minus y1j and then minus z1k. So therefore PQ vector can be written as x2i minus x1i can be written as x2 minus x1i plus y2j minus y1j can be written as y2 minus y1j plus z2k minus z1k can be written as z2 minus z1k. So as you know that in a vector the coefficients of I, j and k are known as the direction ratios of the line or direction ratios of the vector. So here we are identifying direction ratios of the L. Therefore, here the direction ratios of L. Here the direction ratios of L or PQ is nothing but what? L is a line segment joining the points P and Q. Therefore, direction ratios of L, or you may say that PQ. So as you know, the direction ratios are denoted by A, B and C. The value of A is coefficient of I, that is what? X2 minus X1. And B is coefficient of Z, that is what? Y2 minus Y1. And C is what? Coefficient of K, that is Z2 minus Z1. So x2 minus x1, y2 minus y1 and z2 minus z1 are what? Direction ratios of a line joining 2 points. I hope all of you understood. And to find the direction cosines, that is what direction cosines of line L, or simply we call it as direction cosines of PQ line segment. So as you know that direction cosines are denoted by L, M and N. The value of L is nothing but plus minus A divided by magnitude of the line L, or A divided by magnitude of PQ. And similarly, M is nothing but B divided by magnitude of the L, and C divided by magnitude of L is equals to N, or B divided by magnitude of PQ line segment, or C divided by magnitude of PQ line segment. So this is what direction ratios and direction cosines of line joining 2 points. I hope all of you understood. And last concept I written here, that is what? Collinearity of 3 points. Collinearity of 3 points. See here, suppose A, B and C are on the same line, and we need to prove that these 3 points are collinear. And let us consider the coordinates of the point A is x1, y1, z1, and coordinates of point B is x2, y2, z2, and coordinates of the point C is x3, y3 and z3. So to prove that these 3 points are collinear, we just prove that any two vectors joining these 3 points are collinear. So we know that two vectors, A vector and B vectors, are collinear when A vector is equals to lambda times of B vector, or B vector is equals to lambda times of A vector, or A1 by A2 is equals to B1 by B2 is equals to C1 by C2, where A1, B1, C1 are the direction ratios of A vector, and A2, B2, C2 are the direction ratios of B vector. So similarly here also we need to consider any two vectors. You may consider either AB vector or BC vector or AC vector. So among these three you may consider any two vectors, and we need to show that one vector is lambda times of other vector, or direction ratios of one vectors are proportional to direction ratios of another vector. So let's say I am considering here AB vector and AC vector. Suppose if I proved AB vector is equals to lambda times of AC vector, then we proved AB and C are the collinear points. Or you may consider AC vector is equals to lambda times of AB vector, then also the points AB and C are the collinear. Or you may consider AB vector is equals to lambda times of BC vector, or you may prove BC vector is equals to lambda times of AB vector. I hope all of you understand it. Or you may consider BC vector is equals to lambda times of AC vector, or AC vector is equals to lambda times of BC vector. Or in other words, let us consider the direction ratios of AB vector is A1, B1 and C1, and direction ratios of AC vector is A2, B2 and C2. So if you proved A1 by A2 equal to B1 by B2 equal to C1 by C2 equal to one constant value, then also these 3 points A, B and C are the collinear. I hope all of you understood. What is the condition of collinearity of 3 points? We need to prove that one vector is equals to lambda times of other vector, or direction ratios of the first line segment, that is AB, is proportional to the direction ratios of any other line segment. You may consider AC or BC. Then also the points A, B and C are the collinear. I hope all of you understood this fourth concept. So finally I completed what? First one, direction cosines and direction ratios of a line, and then relation between direction cosines of a line, and then direction ratios of a line joining the 2 points, and at last the way of proving 3 points are collinear. So at last what? We need to solve some of the example based on these four concepts what I am discussed in this video. See here. So first example is, so here is the first question. if a line makes angles 90 degree, 60 degree and 30 degree with the positive direction of x, y, z axis respectively, then find the direction cosines. So in this question clearly he has given that the given line makes angle 90 degree with the x axis. Therefore alpha is equals to 90 degree and 60 degree with y axis. So therefore the value of beta is 60 degree and 30 degree with the z axis. Therefore gamma is 30 degree. So when the direction angles of the line is known, so it is easy to find the direction cosines. So as you know that direction cosines of the line denoted by L, M and N, and the value of L is cos alpha. Here the value of alpha is 90 degree. So therefore the value of L is cos 90 degree. Similarly the value of M is cos beta, that is cos 60 degree, and the value of N is cos gamma, that is cos 30 degree. So these are nothing but specific angles of trigonometric ratios. The value of cos 90 degree is 0, the value of cos 60 degree is 1 by 2, and the value of cos 30 is root 3 by 2. So therefore the direction cosines of the given line 0, 1 by 2 and root 3 by 2. I hope all of you understood. So this is one of the important question. So many times asked in your annual examination for 1 mark. But for upcoming examinations, so this question will be asked in your MCQs questions. Because your exam for your annual examination 1 mark questions is already deleted. So they will ask for what? 1 mark, but in which section? MCQ section. And here is the second question. The second question is, if a line has direction ratios 2, -1, -2, determine its direction cosines. In this question already he has given that the direction ratios, and the direction ratios are denoted by A, B and C. The value of A is 2 and the value of B is -1, value of C is -2. So when direction ratios of a line is known, when the direction ratios of the line is known, then the direction cosine L should be equal to A divided by square root of A square plus B square plus C square, and the value of M is equals to B divided by square root of A square plus B square plus C square. Similarly, the value of N is equals to C divided by square root of A square plus B square plus C square. So the value of A, B and C is already given. So to find the value of L, M, N, we need what? Root A square plus B square plus C square. Therefore, the value of root A square plus B square plus C square is equals to square root of A square means 2 square, the value of 2 square is 4, plus B square means -1 square, the value of -1 square is 1, plus C square means -2 square and the value of -2 square is 4. So which is equals to 4 plus 1 plus 4 is 9 and the value of root 9 is 3. Therefore, the value of root A square plus B square plus C square is 3. Hence, the required direction cosines of the required line is A divided by, that is what, 2 divided by 3. Similarly, M is -1 divided by 3 and the value of N, C is -2 divided by 3. So, these are the required direction cosines of the given line. I hope all of you understood. So, let's start the third question. And the third question is, find the direction cosines of the line passing through the 2 points. Let's say first point is P and second point is Q. So we need to identify the direction cosines of the line PQ. So to identify the direction cosines of line PQ, first we need its direction ratios. And as you know that the direction ratios of line joining 2 points, that is nothing but direction ratios of PQ is what? A, B and C, and the value of A is x2 minus x1 and y2 minus y1 and C is z2 minus z1. So let's say the coordinates of the first point is x1, y1, z1 and second point is x2, y2, z. So here the value of A is x2 minus x1 means 1 minus 2, minus into minus plus 2, and similarly y2 minus y1 2 minus 4, similarly z2 minus z1 3 minus 5. Finally the value of A is 3 and the value of B is minus 2 and the value of C is minus 2. I hope all of you understood. Now see here, so we know the values of A, B and C. So this situation is similar to the second question. So when direction ratios of the line is known, then the value of L, M, N is, the value of L is what? a divided by root a square plus b square plus c square, and the value of m is b divided by root a square plus b square plus c square. Similarly, value of n is c divided by root a square plus b square plus c square. So we need the value of root a square plus b square plus c square. Therefore, the value of root a square plus b square plus c square is equals to square root of 3 square is 9, minus 2 square is 4, and then minus 2 square is also 4, which is equals to 9 plus 4 13, 13 plus 4 is 17. Therefore, the value of root a square plus b square plus c square is root 17. Hence, the value of L is equals to. Hence, the value of L is equals to value of A 3 divided by root 17, and the value of B minus 2 divided by root 17, and the value of C minus 2 divided by root 17 are the required direction cosines of the given line segment PQ. I hope all of you understood this third question. So let's start the fourth question. And the fourth question is find the direction cosines of x, y and z axis. See here. Here we need to identify the direction cosines of the x, y and z axis. So see here, let's say this is a x-axis, y-axis and z-axis. As you know that if a line makes angle alpha with x-axis, beta with y-axis and gamma with z-axis, then the value of cos alpha, cos beta and cos gamma are the direction cosines of the line, which are nothing but L, M and N. See here, the value of alpha is nothing but angle made by the given line with x-axis. But here we need to identify the direction cosines of x-axis. It means the value of alpha is angle made by the x-axis with itself. So as you know that this x-axis makes angle 0 with itself. Therefore, the value of alpha is 0. Value of alpha is what? 0. Because 0 degree is the angle made by the x-axis with itself. And angle made by this x-axis with y-axis. As you know that x, y and z are mutually perpendicular to each other. It means x-axis makes angle 90 degree with the y-axis. Therefore, the value of beta is equals to 90 degree. Similarly, x-axis is perpendicular to z-axis. Therefore, the gamma is equals to 90 degree. So, we know the values of alpha, beta and gamma. It means their direction cosines is nothing but cos 0, cos 90 and cos 90. And the value of cos 0 is 1 and cos 90 is 0 and the value of cos 90 is 0. Therefore, the direction cosines of these are what? Direction cosines of x-axis. Similarly, the direction cosines of y-axis. To identify the direction cosines of y-axis, to identify the direction cosines of y-axis, first we should know the direction angles of the y-axis. So it is nothing but alpha, beta and gamma. So as you know that x-axis, y-axis and z-axis are mutually perpendicular to each other. So therefore, this y-axis makes angle alpha, that is 90 degree with the x-axis, and this y-axis makes 0 degree with itself, and this y-axis makes 90 degree with the z-axis. Therefore, the value of direction cosines of y-axis, that is nothing but L, M and N. The value of L is equals to cos alpha means cos 90 degree, and the value of M is cos beta, it is nothing but cos 0, and the value of N is cos gamma, that is cos 90 degree, and the value of cos 90 is 0, cos 0 is 1 and cos 90 is 0. So these are what? Direction cosines of y-axis. Similarly, the direction cosines of z-axis. Direction cosines of z-axis. Here also you need to observe here z-axis is mutually perpendicular to x, y and z-axis. Therefore, the value of alpha is nothing but angle made by the z-axis with the x-axis, that is what 90 degree, and beta angle made by z-axis with the y-axis, that is what 90 degree. and gamma, angle made by the z-axis with itself, is what? 0 degree. Therefore, the direction cosines of, therefore, the direction cosines of the z-axis is nothing but L, M and N. The value of L is cos alpha, the value of alpha is 90 degree, therefore cos 90 degree. And the value of M is cos beta, beta is 90 degree, therefore the value of M is cos 90 degree. Similarly, the value of N is cos 0. And as you know that the value of cos 0, cos 90 values. So the value of cos 90 is 0, value of cos 90 is 0, and the value of cos 0 is 1. Therefore, these are what? Direction cosines of z-axis. I hope all of you understood. So this question is also important. So first this question asks for 1 mark in your annual examination, but for the upcoming years, they will use to find the direction cosines and direction ratios of x, y and z axis for your MCQ section. I hope all of you understood. So let's start the next question. And the next question is, show that the points A, B and C are collinear. So here we need to prove that these 3 points A, B and C are collinear. So as you know that I already discussed it at the time of introduction. So to prove that A, B and C are collinear, we need to prove that AB is lambda times of BC, or AC is lambda times of BC, or AB is lambda times of AC. Consider any two line segments, either AB, AC, or AB, BC, or AC and BC. Consider any two line segments, then find their direction ratios and show that the direction ratios of one line segment is proportional to direction ratios of second one. So here I am going to identify the direction ratios of AB and AC. First I am going to find the direction ratios of the line AB. So let's say direction ratios of the line AB is A1, B1, C1. So therefore the value of A1 is nothing but x2 minus x1, B1 is y2 minus y1 and C1 is z2 minus z1. So here we are identifying the direction ratios of AB. Therefore, point A is x1, y1, z1 and point B is nothing but x2, y2, z. See here the value of A1 is x2 minus x1, that is nothing but 1 minus 2. 1 minus 2 and y2 minus y1 minus 2 minus 3 and z2 minus z1 3 minus minus 4 minus into minus plus 4. Therefore, the value of a1 is minus 1, value of b1 is minus 5 and value of c1 is 7. Direction ratios of the line segment AC. So let's say the direction ratios of AC is A2, B2 and C2. And here the direction ratios of AC. Let's say the direction ratios of first point A is x1, y1, z1 and the direction ratios of the second point C is nothing but x3, y3 and z. Therefore, the value of A2 is x3 minus x1, x3 minus x1 and the value of b2 is y3 minus y1 and the value of c2 is z3 minus z1. Here the value of x3 is 3 and x1 is 2, therefore a2 is 3 minus 2. Similarly, y3 is 8 and y1 is 3, therefore y3 minus y1 is 8 minus 3 and the value of z3 is minus 11 minus z1 is minus 4 minus into minus plus 4. I hope all of you understanding. The value of 3 minus 2 is 1, 8 minus 3 is 5, minus 11 plus 4 is minus 7. So we got the values of A2, B2, C2 and A1, B1, C1, where A1, B1, C1 is the direction ratios of AB and A2, B2, C2 are the direction ratios of AC. To prove that the points A, B and C are collinear, we just prove A1 by A2 equal to B1 by B2 equal to C1 by C2. So that's why consider, consider, consider what? First thing, A1 by A2. A1 by A2, which is equal to, the value of A1 is minus 1, divided by A2 is 1. So minus 1 by 1 is minus 1. And the value of B1 by B2, which is equals to, the value of B1 is minus 5 divided by B2 is plus 5. So minus 5 by 5 is minus 1. Similarly, the value of C1 by C2, the value of C1 is 7 divided by C2 is minus 7. So 7 divided by minus 7 is minus 1. So finally we observed that a1 by a2 equal to b1 by b2 equal to c1 by c2, which is equals to what? Minus 1. Therefore the given 3 points a, b and c are what? Collinear. I hope all of you understood this. So this is all about what? Introduction part for the first exercise of the chapter three-dimensional geometry. So in my next video, I am going to start the first exercise, that is what? 11.1. So I am going to solve the questions regarding with exercise 11.1 in my next video.